So good morning, everyone.
Good morning.
It is my pleasure to all of you over here, and also good morning to all teachers, those who are enjoying our class for today. Today we are going to learn about some waves. Actually, we are going to discover some characteristics for some special types of waves, and as well as the generation. All right, so that is our main target for today. Anyway, so all my dear students, can you please check it out that your physics notebook ready for you? Physics notebook, pen, pencil, calculator, and I hope so you don't have any water bottle, because we will work with electricity. If there is water bottle, it's a big problem. Just keep it on the ground. Anybody? Ah, that's great. Yep. And speak in English all the time, right? For next 40 minutes. Right, that's cool. So here is our lesson objective for today. Please note it down very quick that the generation of mechanical wave and the characteristics of mechanical wave. So these are the lesson objectives for today. All right, so the first one is the generation, and as well as the characteristic. Okay, all right, so these two is our topic, main topic. Characteristics, please note it down to your notebook, everybody. So, all right. So the generation and the characteristics for the mechanical wave. Mechanical wave, right. So this is our lesson objective for today, and at the end of the lesson, I will also ask you some questions regarding this topic. All right? So have you written, everybody? Yeah. Good, right. Now let's go for this one, the student-teacher agreement that as you already signed. You can see over here that everybody signed that you will not speak in English in my class, right? Promise? Yeah. Good, right, that's good. I know you were really very good. And also we're having over here 5 different groups for that Isaac Newton. Raise your hand. Isaac Newton. Good. So the Albert Einstein group. Good. Michael Faraday group. Michael Faraday group. Raise your hand. Then over here, I can't see. Can you just Galileo group, right? So you can see also the name over here, the whole name, and also the Maxwell group. Right, that's good. Okay, right. So you just work together, and I'll give you some work and some activities. So all of you will just do work together, and the team leader, so he or she will come over here, and you just put all those papers and some activities on the board. Okay? Cool. So here's the key vocabulary.
Periodic wave.
Periodic wave.
If the wave moves up and down at the same rate, a periodic wave is generated.
So if the wave will go up and down, right, so it can be a periodic wave. That means, okay. The next one, transverse wave.
Transverse wave. A transverse wave is one that vibrates perpendicular to the direction of the wave's motion.
Do you understand what is transverse wave? Really? And the next one is the longitudinal wave.
Longitudinal wave. If you squeeze together several turns of a coiled spring toy and then suddenly release them, pulses of closely spaced turns will move away in both directions. This is called a longitudinal wave.
So transverse wave, longitudinal wave, periodic wave, these all waves, they are having a common thing, that they need medium to travel. Okay, so whenever you are going to experience any wave, which one needs medium to travel, we will tell that is the mechanical wave. Do you understand? Okay, so this periodic wave, transverse wave, and longitudinal wave, all these 3 waves are in the category of mechanical waves. So already you learned in your previous class that what is transverse and longitudinal wave and the periodic wave. So I'm just skipping this one for the next slide. So the wave property, please put it down. This is very important.
A wave is a disturbance that carries energy through matter or space.
A wave is a disturbance that carries energy through matter or space. So you can see here the matter you can see here the space. So for the matter that is mechanical wave, it needs medium to travel, which is our today's topic. And the space that is for electromagnetic wave, like microwave, radio wave, right, infrared, UV rays, X-rays, gamma rays, these all are the these all are the electromagnetic waves. Means they do not need any medium to travel. Is that clear? So we are having two hands. One hand, mechanical wave, it needs medium to travel, like my voice. Can you hear my voice?
Yeah.
So the sound is a mechanical wave or an electromagnetic wave? Good, right, that's really good. So you can hear my sound because it is a mechanical wave, right? So over here, there are air, and the air is transferring energy from my vocal cord to your ears, and you can hear it, right? Okay, so thank you. Now here's some parts. You can see here the mechanical waves and non-mechanical waves, or the electromagnetic waves. You can see here for the mechanical waves based on vibration, transverse and longitudinal wave. We know that transverse wave, the direction of vibration and the direction of motion, they are perpendicular. And for longitudinal, they are what? Parallel. But though that is not our topic for today. And also the standing waves and progressive waves, they are also the mechanical wave. So we will use these all waves to generation. Okay, all right, so I'll just try to show you that the generation of different types of mechanical waves. Here we are at first, the first activity you can see here. Can you see that? It's a vacuum chamber, all right? Inside there, I cannot see, yeah, can you see that here? It's clear. Over here, there is a buzzer. It can make a sound, like that. So whenever I will make it vacuum, means I'll just take the air out, you cannot hear the sound. But this is light, right?
Yeah.
Sorry, I'm sorry. So if I like put the light, you can see the light. It will travel through it both with air and without air. Can you hear the sound?
Yeah.
Yeah, that's good. We can hear the sound. We can see also the light, right? So the light, the light had gone there, right? Through the air. So whenever this one, I will make it vacuum. The sound is actually coming from the machine. You see that the sound will go a little bit downward. It will be slower, it will be slower, and it will be more slower, okay, or slowest. So at a certain time, you cannot hear the sound. Okay, all right? So without vacuum. But on that time, you can see here, the light is still passing through the vacuum. The light is still passing through the vacuum, but the sound is not passing. I can see here, still the vibrator is vibrating. I can see here, okay, all right? So light can pass through vacuum. Means light is what? Electromagnetic waves or mechanical waves? Electromagnetic waves, right?
Yeah.
That's good. So the light is electromagnetic waves. It can travel through vacuum. Okay? But sound cannot travel through vacuum. Right? So do you understand what is really the meaning of mechanical wave and what? Electromagnetic wave. Okay? Right, that's good. So you can see here the result, sound is mechanical wave and light is electromagnetic wave. Here's another one, the pulse generator.
Wave pulse.
Wave pulse.
A wave pulse is a single bump or disturbance that travels
Anybody
through a
gonna come here?
medium.
So here is the pulse generator. It's a simple machine. You can see here, right? So the energy is transferred. Whenever I like to give some, can you see that? Oh, sorry. So if I give some, look, the pulse, can you see the pulse? Can you see the pulse? Woo, it's going on, right? Can you see that? Ready, 1, 2, 3. It's transferring, right? Ready, 1, 2, 3. Wow, it's so fantastic. Right? Amazing. So if you like to give the energy over here, look, the energy is transferring, propagating. So tell me, this one is mechanical or electromagnetic wave? Mechanical, you can see here, right? It's a medium. And if I like to give some energy on it, so it is propagating, right? So this is also a very cool experiment to understand the generation of mechanical wave. So over here, we are actually generating the mechanical wave, right? Thank you. That's really good. Okay. So this is the second one for the mechanical waves, for the wave pulse. Another card activities, I have given you the card, right? Can you see that? I've given this type of one card to all the group. Okay, so I'll give you some time, just take some time, discuss among yourself that your card, it is the mechanical wave or the electromagnetic wave, which one? So you need to come to the board and you just stick it over here. Like the first one, okay, Isaac Newton group, come the group leader, please come. This one is microwave, right? What do you think microwave will be the group member for mechanical wave or electromagnetic wave? Just discuss. So please discuss among yourself, the group members. Discuss with your friends. How many people can understand this is mechanical or electromagnetic? Yes. So what's your group name? Your group name? Newton. Yeah, put it here. Yeah, that's good. Okay. So next, all groups come quick. Only the leader of the group come very quick. Yep. Come very quick. Quick. Your group is Einstein. That's good. Your group Galileo. Very good. All right. Yep. You two group. Come. Quick. Yeah. Is the discussion done? Who's left? Yeah. It's Maxwell. So this is Maxwell. Right. Yes. Oh, you do not have that one? Yeah, I can give you. Come. Hello. Yeah, I have. What do you think? Your group members, what they're thinking? Faraday, Michael Faraday. So the team Einstein decided that the water wave is mechanical wave. What about other groups? Do you think that water wave really is a mechanical wave? Yeah, that's right, correct. That's really good. And also, Team Newton, microwave is the electromagnetic wave, right? Yeah. Good, right. The Maxwell group, radio wave is also a mechanical wave, right? Yeah. Good. And the Galileo group, light, I showed you at the beginning. Yeah. So light is also a electromagnetic wave, light, radio wave, and microwave. And also the sound wave is what? Mechanical wave, because it needs medium to travel. Right. Yeah, so I'm really pleased to all of you. So all these group members, you'll get 10 points, 10, 10, 10, and 10. At the end of the class, which group will get highest mark, I'll give a prize for them. Okay? So here we are, the examples of the mechanical waves, you can see there. Okay, already I think you understand. And these are the examples for the electromagnetic waves. I think that's clear, right? Yeah. Now you can segregate, you can differentiate between these two waves, because you need to understand which one is what. Then after that, we'll go for the generation. Okay? Good. Now this wave machine, I need somebody, a healthy man. Anybody? Come with me? Come on. Yeah, okay. Just hold it tightly here, so that everybody can, you can come on this side. Be careful. Yep. So this is a fantastic demonstration to understand the generation of mechanical wave. So you can see here, these all are the points. Like, if I like to use this one, right? And if I like to put it like this way, so it is making what? Wave. This is a mechanical wave, right? You can see a medium. And which side I am transferring, so it is just going on to that way. Okay? Now look, ready? 1, 2, 3. Only first. Only second. Right? Third. All points have gone up, right? So all points are indicating with the first point, the indicating points, right? Like the leader, like for a country, if the leader is the excellent, the whole country will do, develop very quick. So the leader is very important. Here, this point is the leader of this whole full wave. If this point will go up, all points will go up. If this point will go down, all points will go down. Right along. So where the first point will go, so all the other points will just follow it. Let's go to see it over here more good way. Now you can see here, can you please stretch a little bit more, stretch straight? Okay, all right. These all are the points, be careful. You can come here, just check this part. Come here, hold this side. Hold this side. Yep. Now you can see over here first 1, 2, 3. You can see that the wave is going on and wave is coming back. Wave has gone, wave is propagating, and wave is again coming back, right? Let me do it one by one. Let me do it one by one, like the first one. Like the first. Okay, hold it with your hand. Hold it with your hand. Okay. So ready? Just ready? 1, 2, 3. So like the first one. So it's going on and again coming back. So each group, like the Maxwell group, you just observe this color. Can you see the color? I put the color purposely. So the different group, you can see, just you will observe only this color, only one point, like this last point, okay, all right? How the points are going. This group, you just observe this green color, all right? Can you see that? Last, can you see this one? This one? So target in one point, like this point. You just watch this point. Then this group, Einstein group, this one, okay? Just focus this point, one point, and you just focus this point, the last one. Now, after that, I'll ask you one question. Okay, ready? 1, 2, 3. It's going on the wave, and again, it's coming back, right? Again, ready? 1, 2, 3. It's going on, going on, going on, going on. Now it's coming back, right? Here, end. Wave propagates. Wave is going from left to right, but these particles, actually, they are just jumping up and down like this way, right? Means the particles are not running in this way, right? Particles are not running. Particles are what? Particles are, all of them, they are in their position, and then they are just going up and down, right? So actually, this is the main outcomes over here, the propagation or the generation of mechanical waves. So this is the way we can generate the mechanical waves. That from my hand, I am transferring energy, and that energy is transferring from left to right, and again it is coming back. So the energy is transferring, but the particles are not. Particles are just moving. So if the particles are moving up and down, and if the energies are going to the other direction, we can tell this one is transverse wave. Okay? As the key vocabulary. That if the particles will move up and down, but the waves are going left to right. That is what transverse wave. Okay, thank you. Just fix it. Do you have any question? Is it okay? Do you understand? Okay, good. So this one is transverse, and can you just help me to do that? You can see here, this is the longitudinal one. For a spin, please come here. Anybody? Believer? Believer, come here. Just hold to that side. Just hold it. Now you can see here, look, the waves, right? The waves are going on and coming back. So the movement for the wave, the movement is also from my side to the believer's side, the movement of the particles. And the direction of wave is also from my side to his side, and also coming back and going back, right? Coming and going. Here, the direction of the movement of the particles and the direction of wave, both of them are parallel. So that is called what? Longitudinal wave. We learned already. This is just a repeat topic. So do you understand longitudinal and transverse wave? But both of these two waves are mechanical wave. Why? Because they need medium to travel. Right? Good, fantastic. Keep it here. Right. So here we are. Derive, delay, repeat. So you can see here that these three topics, they are related. like the derive, delay, and repeat. So the first derive, we are deriving energy first, right? Like over here, derive. After the delay, at the last point, it will be a little bit of delay, then it will reflect back again. So the wave will come, a little bit delay, and it will come back, right? So these three processes, you can say these are, I'm having tips like dance, dance, revolution. Dance, dance, revolution, right? So first dance means derive, second dance means delay, and third dance means repeat. So all these three together. All right? So these three are the key words for the generation of mechanical waves. Okay? Please note it down, these three words, because we need it after that. Oh, and also thank you for Mr. Vaskar and also Miss May and the whole physics teachers team to build that awesome generation machine, that wave generating machine. Actually, these people, they had given lots of effort to make it. Okay, so please give a clap for them. Yeah. Right, the next one is the ripple tank. Now the water, have you written this three? Yeah. Good. So now see here, the ripple tank. This is also a very good demonstration for the generation of mechanical wave. So the water wave, T. Einstein today discovered that the water wave is what? Mechanical wave, right? Yeah. So here's the water wave, and here you can see a stick, and the stick is going up and down. Okay, all right, so the stick is moving up and down, and the water is spreading, propagating. So this wave is what? Mechanical wave. And you can see here the generation of mechanical wave. So this point is coming, and it is just transferring energy to the surface of the water. And after that, what is happening? So after that, what will happen? So after that, from here, the energy is transferring. Okay, all right, so this is also a very good demonstration to understand about the generation of mechanical wave. I think the slinky spring already I told you, already I showed to you the slinky spring. All right. Let me see the video over here.
Mr. Peterson, but the displacement will be perpendicular to the propagation.
Okay, so let's go do this experiment too. Anyone? I think so, I'm not sure. Can you see from here? This is also another very good demonstration to understand about the generation of mechanical wave, right? Like if I like to give it this way, can you see that? It's going up and down, up and down. Can you please come and help to remove this one, please? Just keep it there. So the first one is, see over here, up and down, right? It's going on and coming back. And the second one, can you see that? It's going on and coming back. It's going on and coming back. That means this is also a good demonstration for the propagation of mechanical wave. I put it down. So now it's a good view. Okay, you can see, right, everybody? Yeah. That's for you, I actually made it high so that everybody can see it, right? So first from here, look, it's coming down, right? So I'm giving the energy, from my body, and it's coming back to me. So generation of mechanical wave, as well as, this is what, the propagation of energy, as well as this one is what, the longitudinal wave. That is the family member for the mechanical wave. And this one, look, see here, 1, 2, 3. You see that, look, I'm giving, it's coming back. I am giving, that is derive. First one, derive, a little bit delay, then again, coming back. That is what? Repeat. So what I am giving here, this is derive. I am the driving person, right? Everything is in my hand. If I wish, I can take it out, or I can just keep it inside. So the drive, my hand is driving point. Then after that, delay. At the last point, it will be a little bit of delay. Okay, right? If I will give you some comment, you will take some time to understand. Then you will reflect back, right? Delay. And then again, it will come back. You understand? So all type of mechanical wave, you can find these three properties. As I showed you over there, the water wave, and also the slinky spin, all of these cases, right? Okay, thank you. Let's go for the next activities. This is for the human wave, right? Anyone? 5, 6 people, can you please come very quick? And let's go to make a human wave here. So let's go to build this human wave. Then after that, I'll also ask you a question. Come on, come, hand with me. I'm the driving person. I'm the driving force, right? Come, quick. Let's be ready. So this is the driving. Okay, right? So follow me. That's what I am doing. Then whatever I will do, they will follow the same thing, right? So I am drive, right? They will go. The last person, believer, will take a little bit of time. Then again, he will reflect back, right? So delay, and then whenever it will come back, that is what? Repeat. Great. Yeah. So ready? 1, 2, 3. Right? Do you understand? So this is only the drive part. Ready? 1, 2, 3. 1, 2, 3, and 4. Right? So these are the wave, and we are generating mechanical waves. And each person over here indicating what? A particle. Which particle is just moving up and down. But what? The energy is going on from left to right, right? Please give a round of applause for this great voice. All right, okay, let's go for the next one. All right, so that means the generation of mechanical wave, we understand, I think, very good way, right? So if you have any question, you can ask me. Do you understand? Yeah. Good. Now let's go for the characteristic of mechanical wave. Like the character for a person, character for anything, right? So we are going to define the characteristic of these mechanical waves. Here, all the group members, you will do some activities. Already I had given it to you. I'll just explain you shortly that how you need to do it. Then you will find the characteristic. I am not going to write it on the board. Okay, right? You will do some experiments. You will just discuss among yourself. You will decide, and then you will come to me. That, okay, all right, sir, maybe this is the characteristic. Okay, so I'm giving some hints. The first one is the starting direction. I think, can you please find all of in your group this type of one thing? All the group members, can you please check your group? Do you have this one? Ribbon stick. Do you have this ribbon stick? Check it out. Do you have this ribbon stick? Everybody, can you do it? Can you show me that you have or not? Can you show me one? Ah, that's good. Fantastic. Everybody? Show me the ribbon stick, quick. Yeah, that's good. This team is ready. Einstein team ready. Faraday, make it quick. Galileo ready. Maxwell ready, right? Ah, yes, it looks good, right? Okay, I think everybody's ready now, right? Look, okay, all right. Look, okay. Thank you, okay, stop it. Thank you. What you need to do, you will decide the starting point, like the leader. Starting point means the leader, right? So the leader's direction, the starting point's direction, it is same as the wave source or different? Same like wave source. Over here, wave source is your hand, right? If your hand is moving left or even the right, where the starting point will go and where the other points will follow. Okay, right? So you will think it and you will talk. This is number one. Number two is the periodic motion for the SHM. I have given you some sand. Can you see that? Just please find it out. Sand. Over there is some sand. Can you see the sand? Okay. And also I have given you a small cup like this. Can you see that? Like the small cup, like this. So I'm just demonstrating that what you need to do. And also you are having a clamp like this. You're also having a clamp like this, right? So you can just fix it over here on the clamp. All right. you need to put the sand here, and with the sand it will go left to right, okay, like it will oscillate, and you are having a big paper, okay, right? With this paper, two people, one people will just hold it here, and very quickly, look, see, at first see, try to understand what I'm doing. So one person will hold it this side, another person will hold to the other side, okay, right? While it will oscillate, on that time you just go very quick on it. Then you can see something here, okay? By using that one, by observing that one, do you think that it is a periodic motion like this? Mechanical wave is a periodic motion or not? So you will just do it whenever I will tell on that time, just do it and give me the answer. This one you will discover, okay? Third one is the frequency of mechanical wave. You are having a ball, that is thermocol ball, though that is not here. So the thermocol ball, and you are having this type of one fixed frequency, and also you are having a pith ball. I wonder where is my one. So find one pith ball that is in your, that is not here, okay, all right. So even you can just, okay, and if you like to just put it very close to it, you can see that the energy is transferring, propagating, okay? And if the frequency is more, you will see that how it is changing. And if the frequency is less, the different one, so how it is changing, okay? You will find it out. So this is for the frequency of mechanical wave, like this, okay? It's transferring, right? So automatically it's going on. So you will find it out, the relation. Okay, and the fourth one is, you can see a powder, you can see a ball here. So please make it a little bit tight, make the surface very tight, all right? Be careful, it should not be, what is that called, tear, okay? Not like me, so be careful about that one. And you just put some sand here, like this one, just make it very tight, okay? Then put some sand here, and also put some sand, and after that, though actually my one is not so hard, and if you like to also, you can see that it's amazing. Without touching, you can see that the energy it will transfer. Okay, right? Yeah, you can see that. Look, so it is transferring energy without touching the sand. Okay, but be sure that this one is very much tight. The surface is very much tight. Then this experiment will be awesome, right? So these are the four characteristics for the mechanical wave you can discover from these four experiments. So your time starts now. I will help you if you have any technical problem. So let's go to do it. Discuss among yourself and tell me what is your outcome. Here, right? Yeah. Hold it here. Hold it. Yeah. Put it then after that. 1, 2. Yeah. This one is like that. Fix it here. So do one by one. Okay, let's go do at first this one. Okay, all right. Where is the paper? Keep the paper here. Okay, all right. Put some sand. Just do it quick. Yeah. Straight. Stand straight. You can do this one together. Just hold it and find out that these tools are different or same. Is the frequency is transferring to the ball? Sorry, the energy is transferring to the ball or not? You can make it down. Yes. Actually, these experiments we're doing for the simple harmonic motion. It is, check it, I think it will work. Yeah, just use your common sense. Yeah, can you see that? It's a sinusoidal wave. Right? Yeah, good. You can put it a little bit down. Is that okay? Yeah, you can just keep it here, no problem. Just do it again. Just do it again. Okay, all right? You do not have that. Yeah, this one, yeah. Put it this one, like this way. Yeah, so if you can just go very close to it, you can find that the energy is transferring again. Yeah, look, the energy it will transfer. Just be careful, very closely, and do it again. Do yourself. And discuss among yourself that how it is working. Okay, what do you think about the characteristic of mechanical wave? Okay, you will discuss among yourself and write. The leader, you will write, or anybody will just write it down. Okay? Then I'll ask you the question. Is it all right? What tungsten? Yeah, right. Yeah. Actually, it is not coming out. The hole is not that much big. Do you have the pen? Yeah, right, that's cool. Now it will work. I put it here. Put the old sense here. All right, ready, 1, 2, 3. Ready, 1, 2, 3, right? 1, 2. Wait. Yes, yeah. Slowly. Look, this one, it will move from here to here, okay? Now it will come in, now it is coming. Look, now it is coming. So this will come like this way. Okay? Good. Take your time, relax. Okay, all right? And if you're ready, so just tell me that you are ready. Yes. Yeah, we found here. Very good. This way, this side. Yeah, this side. So what? Ready? 1, 2, 3. Actually, we are trying over here to generate the mechanical wave. All right? Like this way. Yeah, it's coming now, right? It's coming. Look, you can see the wave, right? Yeah, now you can see the wave. Look at it like the wave. So we are generating the wave. All right? Okay, all right. Team Newton, sir. Team Isaac Newton, right. So what do you think about number 1? Please, silent. All right. I think I've seen that all the groups. It's okay, all right. Your experiments are okay. So the starting direction for the mechanical wave. What do you think that? It will be same or it will be different? Same, right? So you understand by using the ribbon stick, right? That's good. Now the second one, simple harmonic motion or the periodic motion. Better to tell periodic motion. Okay? So do you think that the mechanical wave, it will follow the periodic motion or it is not? It will follow the periodic motion, which is going on and coming back, right? Good, right. So that means this is the periodic motion. And also the frequency of mechanical wave. What do you think that? The frequency of forced oscillator, that is same like your driving force, is how much you are giving the force, like the frequency. Suppose that this one is having a fixed frequency, right? So how much frequency we are using, so it can transfer that type of frequency, right? That type of frequency to its neighboring points for the mechanical wave. And also the fourth one, for the wavelength of mechanical wave. So that is actually for the one time period, it will what? Complete one wavelength. If it will just move one, so within a time period, it will what? Just travel one wavelength, right? I can show you the wavelength from here, though that is the standing wave, and this one is also a good example for the mechanical wave. You can see over here the two waves, right? Can you see here the two waves? So from here to here one, and from here to here the another one. So we can also find from here the wavelength. We can also find from here the wavelength. Can you see it? Yeah? You can see here the two, from here one and from there one, two. So here we can understand the wavelength of the mechanical wave, that is also same. So just a very quick questions. Mechanical waves need medium to travel, true or false? Yes, so mechanical waves need travel. Good. Now the electromagnetic waves do not need medium to travel. What do you think? Correct, right? Electromagnetic waves do not need to travel, right?
Yeah.
Good. And the third one? Starting direction of each point is the same as that of the wave source. What do you think?
True.
True, right?
Yeah.
Good. That means you understand it in a very good way. All right, so here's the lesson summary for today. Okay, all right. I'm really thankful to all of you. So thank you very much for understanding. Do you have any question?
No.
Okay, so thank you very much for your great cooperation, and thank you to the all teachers. See you next time. Bye-bye. Everybody take this one and say thank you to all of your teachers. Take it to your hand. Ready? 1, 2, and 3. Say thank you. Thank you to all of you. Thank you. Fine. That's really good. Okay.